Hello everyone, this is the first lesson recording for IM1, March 9th, 2021. Do you ever feel like this woman? Some days you feel like a superwoman and you're ready to tackle the world and there's your cape flying away, and then some days you just feel like sleeping underneath your cape. Well, at least the cape has dual purpose, right? Alright, announcements. There is no outreach on Wednesday. That means that Wednesday is a day. So you will have period 4, 5, and 6 with me on Thursday. On Wednesday, you'll be going to your period 1, 2, and 3, whatever they are. And instead, you're going to have Friday off. Friday is going to be your day off for you. So this week is going to be a short week. We're going to start by thinking about which one is bigger. So please tell me in private chat. If you had choice between 5 and 5.1.5, do you see the difference between that dot and that dot? What does that dot mean? And what does this dot mean at the bottom? Hopefully you're telling me that dot here is multiplication and this dot here is a decimal place because it's at the bottom. Okay? If in your notebook that it is not very clear, just so that you do not make it yourself, you can always use parentheses to indicate multiplication. Okay, so the question is 5 going to be bigger in number, or is 5 times 1.5 going to be bigger? Which is the bigger number? And the bigger number is 5 times 1.5. If you actually use a calculator, you'll get 7.5 as your answer. And 7.5 obviously is bigger than 5. Okay. What about this? Between 5 and 5 times 0.7. Which is a bigger number? Okay. The bigger number is 5, because if you use a calculator and you multiply 5 times 0.5, you're going to get 3.5. 5 is bigger than 3.5, so this is a bigger number. Okay, so this should basically tell you that when you multiply a number by a number multiply a number bigger than 1, if you multiply a number by a number that is bigger than 1, like 1.5, the number is going to get bigger. However, if you multiply by a number that is smaller than 1, like 0.7, the number is going to get smaller. So 1 is the cutoff point. If you multiply by a number that is bigger than 1, then the number is going to get bigger. If you multiply by a number that is smaller than 1, the numbers are going to get smaller. Let's try the different one. Okay, how about this one? 2,900 multiplied by 1.5 times 1.5 times 1.5. Okay, so we are multiplying 1.5 4 times here, and here you are multiplying 1.5 2 times. Which is going to be a bigger number? The bigger number is this, because it's going to get bigger by 4 times, whereas this is going to get bigger by 2 times, right? So the proportion is still 1.5. but this is going to get much bigger. What about this? Which is the bigger number? Okay, you're multiplying the same number, 2,900, but here you're multiplying by 0.8, 1, 2, 3, 4 times, and 0.8 just 2 times. Remember, we said that if you multiply by a number smaller than 1, then the number is going to get smaller. And so it's going to get smaller, smaller, smaller still, and then smaller still. It's going to get smaller sequentially, a lot more with C than D. So D is going to be our bigger number. Let's keep going. Which is a bigger number now? Okay, so if you have 27 multiplied by 0.5 to the power of 10, that means 0.5 is multiplied to itself 10 times. Okay, and then you're multiplying 27 to it, versus 0.5 is being multiplied 12 times, and then multiplying that to 27. So you're multiplying 27 to both of them, but the difference is 0.5 is being multiplied 10 times here, and 0.5 is being multiplied 12 times here. Which is going to be the bigger number? Well, as you multiply 0.5, it's going to get smaller. Okay, so it's only going to get smaller by 10-fold, while as this is going to get smaller by 0.5 12-fold. So this is going to get much more smaller. So A is a bigger number. What about between these two? This time we're multiplying by a number that is greater than 1. We're looking for which is the bigger number, because as you multiply 2.5, the number is going to get bigger and bigger and bigger. So it's going to get bigger more times with D than with C. So it's going to be D. So you're going to take some notes here. There are two types of exponential function. One is called exponential growth and the other is called exponential decay. Exponential growth is where you start with a value and then repeatedly multiply a number by a number that is bigger than 1. And then as you do that, the values are going to grow bigger. As opposed to exponential decay is you start with some number again, but this time you're repeatedly multiplying by a positive number but smaller than 1. So we're really talking about a number greater than 0 but less than 1. And in that case, the values are going to grow smaller. The example of exponential growth was our zombie infection. And we multiplied by 3. The multiplier was 3. And what about the salary raise? We multiplied by 1.08. Remember the 8% increase? But we added not just 0.08, but we added 1 to it. So the multiplier was 1.08. What about, so in this case for exponential growth, both the cases, they are exponential growth because the multiplier is greater than 1. What about exponential decay? The example was the tennis ball bounce height. And in this case, the multiplier was 0.55 because we were going for the bounce ratio to be between 53 to 58%. Or most of us came up with 0.55. So in this case, the multiplier is smaller than 1, but it still needs to be positive, so it has to be greater than 0. Looking at the graphs of exponential growth and decay, exponential growth graph would always look like this, starting very small and then increasing. This is the shape. Exponential decay, it is you're starting at some value and then it's getting smaller and smaller and smaller, and it approaches 0 eventually. This is where you have a value and it gets bigger. That value is getting bigger and bigger and bigger. Okay, that's the y value. Is getting, in this case, much bigger and then much bigger. It looks like 2.5 times and so on. Whereas in this case, the y value is the starting value is 10 and it is getting smaller by the factor of 2 and then smaller and smaller. Okay, so the y value is getting smaller and smaller and smaller. Okay, but you are still multiplying by some number, but you're multiplying by a number that is less than 1. Here you're multiplying by a number that is greater than 1. That's why it is growing. What about tables of exponential growth and decay? This is one of the examples of exponential growth because as the x is increasing, the y values are increasing. And not only are they increasing, but you are multiplying by same number, 1.5. And remember the multiplier, the number that you're multiplying, because it is greater than 1, the numbers are increasing. What about exponential decay? What's going on here? The y value is decreasing, but not only that, you're multiplying by say a half, or dividing by 2 is same as multiplying by half. And so 80 to 40 is multiplying by half, and 40 to 20 is multiplying by half. Remember we said that exponential decay is when the multiplier is positive, that means it's greater than 0 but less than 1. So it's between, half is between 0 and 1. So this is going to create an exponential decay. Here you're still taking more notes. Equations of exponential function. Y is equal to a times b to the power of x. This is the general form of exponential function, where x is the input variable and it's usually time. Okay? And then y represents the output variable. It could be like dollar amount or the population or number of things or anything like that. A represents the starting value when x is equal to 0. What is the value that you're starting with when x is equal to 0? So graphically, this would also be the y-intercept value. Okay, A will be the y-intercept value. What is the B? B is going to be the multiplier, the number that you are going to multiply to the previous number to get the next number. And it is repeatedly multiplied to the previous number to get the next number. And the multiplier is going to be growth, create exponential growth if b is greater than 1. Remember, the numbers are going to get bigger and bigger and bigger if the multiplier is bigger than 1. And if b, the multiplier, is between 0 and 1, then it's going to create an exponential decay. We can also represent this as b is greater than 1 or b is less than 1 but greater than 0, or b is between 0 and 1. Okay, so with that, you are going to work on Desmos activity, card number 1 to 7. So please pause the video and try to work on those yourself. So the first question is asking you, is this a graph of exponential growth or decay? The y value is going down. So this is not growing, it's going down, so it is exponential decay. And you can explain your thinking there. Okay, what about this table? Is this going to be growth or decay? Are the values going up or down? Okay, so it is going up. The values are going up, but we need to make sure that it is exponential. Okay, so that for it to be an exponential, that when you need to be multiplying by the same number. Okay, so how do I figure out what the number is that I'm multiplying by? You figure out whatever the number is and divide by its previous. That's previous is 40,000. You divide that, and that's going to be 1.5. That means to get from here to there, you multiply by 1.5. Let's see if this is the same here. Okay, so that's 90,000 divided by the previous, that's 60,000. And again, that is 1.5. So, and that's going to be the same all the way. So you are multiplying by 1.5 and you're multiplying by 1.5. So the number is the same, the number that you're multiplying is the same, and the numbers are increasing, as well as because you're multiplying by a number that is greater than 1, it is going to be exponential growth. And you can explain that. Card number 3. What about this equation? Okay, is this exponential growth or decay? What determines whether it is growth or decay? It's the multiplier, right? Where do you find the multiplier in an equation? 3 is the number without the x exponent. The value with the x as exponent is the multiplier. That means we are multiplying by 2.4. So we are multiplying by 2.4. The multiplier is 2.4, or it is greater than 1. So it is the numbers are going to get bigger and bigger, so it's exponential growth. Number 4, is this exponential growth or decay? This graph is exponential growth because it's getting bigger and bigger and bigger as you go from left to right. And what about this equation? Okay, so 3 is the initial value, 0.4 is the multiplier because that's the number with the exponent of x. That means 0.4 is the multiplier. It is less than 1, so it is going to be exponential decay.